Hey everyone, welcome to Science This Week. Today we're going to be talking about a interesting topic in my opinion, since we're wrapping up the rest of the school year here in these next couple weeks. Today we're going to do a lesson on black holes. They seem to be something that a lot of people are interested in. I get suggestion pretty much every year that people want to know more about them. So here's my take on them. They are extremely mysterious still, even nowadays when we do know a good amount about them. So feel free, maybe this will inspire you afterwards to go do your own sleuthing and learning about them and other like crazy astronomical space objects that are out there that I'll show you in this. All right. So if you want to actually know about black holes, there's a couple of things you got to know beforehand, and hopefully by the middle of this, what the black hole actually is will hopefully make a little bit more sense to you. So this is like seriously advanced, and I'm going to try to make it as age appropriate and content appropriate and 8th grade appropriate as I possibly can. And if you want to know more, feel free to go out and learn about it. So here we go. Very exciting. This is the first ever black hole photograph. And you're probably thinking, wow, that is really underwhelming. It's very blurry. But this was a monumental moment in studying black holes. So this was actually very recently. This was, pretty much last year. So April 10th, 2019. Big deal. You could search it on YouTube when they unveiled the photo. You could type in like first ever black hole photograph on YouTube, and I'm sure you'll see when they actually unveiled it. So, how did we figure out what the heck these things were? It's pretty complicated. We figured out by math that these black holes can exist, but a lot of people didn't believe it. Especially Einstein at the time. He didn't actually believe that black holes were possible, even though the math proved that they were possible. But we had no sightings or findings of any of them. So what ended up happening was these scientists went on a limb and developed a instrument that detected these things called gravitational waves. And it's crazy because they didn't even ever hear of these things called gravitational waves before they built the instrument. It was a gamble, essentially. They built an instrument and they were hoping that they can aim it into space and detect these gravitational waves. And spoiler alert, it ended up that they actually did detect them. And what they were, it wasn't like when you detect light from space. It was detecting literally gravity. And it was this little chirp sound like a bird outside that you would hear. That's what the telescope essentially picked up, a little bit of sound. And the sound was gravitational waves. And what it ended up being after further study was two black holes very, very, very far away. I think it was like 1 billion light years away. They were swirling around each other like in this picture here. So imagine two black holes and they were like swirling around each other. And once they collided, they let out this ripple effect through space. Like imagine if you throw a rock in your pool like really hard, you would see these ripples that go everywhere. This instrument over here on Earth was able to pick up these waves. And it actually took millions of years for the waves to actually get from the black hole to us. And it just so happened that it was in 2015 when they actually ended up coming to the detector, and we ended up having the detector. It was very, very, what are the chances of that, So we picked up these gravitational waves, and that was actually huge proof right there that the black holes had something to do with gravity. So that was big, because we didn't know what they were, but we knew now that it had something to do with gravity. So here's what we know right now. Black holes. They're the most mind-blowing thing in the universe. There is nothing right now that we know of that's as strange, mysterious, or powerful as these things. Albert Einstein couldn't accept them that they were real. He didn't actually want to accept that they were real. He said that nature shouldn't do such a thing. They have infinite density, meaning they are composed of a ton of stuff in a very, very small volume. They have no beginning and no end. They pull things in and they warp light around it. We have really difficulty explaining them with science and math. And essentially, the blue I wrote down, it's a hole in the fabric of space, and there's nothing there except intense gravity. So this is the part that I want to tell you about next. Fabric of space, because you know what gravity is for the most part, but we're going to get into what it really is in a second. So the fabric of space is interesting, and this was all of Einstein. So he said that outer space is like a blanket. So imagine a blanket, and certain planets or objects actually sit on the blanket. And you can imagine this like a trampoline. If you've ever been on a trampoline, you know exactly what I'm talking about. You sit in the middle of the trampoline, and the trampoline like warps underneath you, right? It was eventually flat, but if you put yourself on the trampoline, it warps underneath you. That's what planets do to space. That's what stars do to space. Anything in space warps space, and it like sits in it like this. So obviously in my picture, the moon here and the earth has a bigger mass, so it's going to warp space more. The bigger the object, the more space is warped. So this is all Einstein stuff. This is what he pretty much dedicated his life to coming up with. So the mass of every single object in the universe causes the space around it to curve and bend. And it's interesting because if you think of going back to the Earth here, the Earth has this bowl shape around it. And the moon actually orbits the Earth. What it's doing is it's just going around the curve that the Earth is making in space, like draining water, essentially, like in this picture here. So the moon is literally rolling around, or in this case, the planet is rolling around the sun forever in this curve that the sun is making, like a bowl in space. This is called being in orbit. So when you think of planets orbiting around other planets, they're rolling around space because that object that it's orbiting around is bending and warping space. And like this picture, it's circling around it. So it's pretty cool. Everything in the universe makes space warp, and if there's something orbiting in it, around it, it's just going around that bowl forever, essentially, until something else happens. Like obviously if an asteroid hits the planet, it's going to knock it off course. But right now, everything is nice and balanced. It's pretty cool. And we know this is for a fact. The whole orbit thing is because we put satellites in orbit all the time. The International Space Station has people around it living in it right now that are orbiting around the Earth. And we know exactly what speed we need to travel around the planet in order to get things to stay in that curve. That's why we have like thousands and thousands of satellites that make your cell phones work and GPS work. They're all falling around the Earth right now. It's pretty crazy. So here's an idea of how much things warp space. So check out the sun. The sun's really, really, really big, and it warps space about that much. You can see in the picture. A neutron star is a really, really dense object. It warps space about that. But look at black holes. That's a humongous warp. So it's crazy. Now, if you look at this picture, there is a line here called the event horizon. This is the spot which, if anything goes past, it can no longer get out of the warp. So it's gone forever. It just goes into infinity. And we don't actually know what happens past that point. This is where you see in the picture, it's all black. And you'll see in a couple of slides what I'm talking about. Here is a student's rendition of a black hole warping spacetime. I thought this was hilarious, so I had to put it in. So they drew a normal object creating a dent and bending the space. And then look, this is their black hole one. Yeah. Whatever. This one's better, but this is what someone came up with. Okay, so how are they formed? This was a picture of that the Hubble Space Telescope took. This is a telescope that's in orbit around the Earth, and it took a picture in a very small spot in the sky, and it came up with all these stars. These are all stars, every single speck. Now you can see a lot of the stars are different colors and sizes, and they're different distances away, and they're different luminosity, how bright they are. But sometimes, if a star is big enough, it could turn into a black hole. So every star has a certain life cycle that they go about, just like humans. Like we go from a baby to a toddler, to a child, and then a teenager, and then young adult, and old person, and then you die, right? Same thing happens with a star, except it depends on how big they are. So the only way you can end up with a black hole, if you look at these arrows, you have to go from here to here to here to here, supernova, and then you can maybe get a black hole. Only the biggest of the biggest stars can become black holes. It's all about their mass. And sometimes if the star is big enough, you're going to get a supernova explosion like this. Gravity is going to win the fight and the star explodes. This is its death, and all that's left after that is a black hole. So here's sort of what you get. This is a computer image, but it's mathematically sound, so this is pretty much what they look like if you were to see one, maybe. And if you were to go back to the beginning, if you remember what this picture looks like right now, and I go all the way back to the beginning, see? This is the actual picture in real life. Obviously, we don't have very good, technology to get a great picture, and this is what we're at right now. Okay, so there's a couple things about it. The outside of it, where you see all this smear, this effect is called gravitational lensing, and what it's doing is the light is actually being pulled into the black hole, so it like smears the light. It like blurs it all together. You could see out here, normal, but as you get to certain areas of the black hole, the gravitational pull is so great that it actually starts warping the light. It starts stretching it out, essentially. So this area around the black hole here is called the accretion disk. It's where all the objects are starting to get pulled in, essentially. All the asteroids or rubble or matter, whatever it is, they're starting to get pulled in. The point right here, the edge around the nothingness, is called the event horizon. This is the point at which nothing can ever get back out. So if you somehow get past there, it's impossible to come back. And we don't actually know what's in here. No idea. And we don't have the means to get to one because they're too far away. So what happens near or in a black hole? It's very weird. So this is mind-boggling, but this is what's going on. If you were to go near the black hole, you would actually see all of time start to speed up like crazy. You would see the entire universe unfold right in front of your face. Everything would just go. It would be like everything is in warp speed and just advancing in time. However, the opposite is happening to someone watching you. So if I'm on Earth and I'm watching you go to the black hole, I would see you as pretty much frozen. You would be in slow motion, like barely moving. But to your point of view, you would see everything going by like light speed. It's very weird. So time gets warped around a black hole. We have no idea what's inside one, but we do know, and we invented this word, it's called spaghettification. Your body will actually start to get stretched, like in this picture that I found on Google, this great picture, until you are one atom thick. Like this, all your atoms are literally lined up one by one, and then you are pulled into past the event horizon, and that's the end of you. And you'll eventually just be crushed and become part of the black hole. Yeah, great. So math shows that 100 million black holes are in our galaxy, and we have found 12. So a lot of them are invisible, or we don't have the technology to detect them yet, but there's a lot of them out there. They're very, very common. So that's your little mind-boggling tutorial on black holes. If you're interested in more black hole stuff, there's a ton of stuff on YouTube. There's documentaries on Netflix and all those streaming services that you can look up, like universe and black holes and stuff like that. These pictures right here are really crazy. There's a lot of crazy stuff in the universe. These are called gamma ray bursts. It's the most energetic event in space. So you can feel free to look that up. You could check out quasars, pulsars, neutron stars. These things are all crazy things that are equivalently as awesome as black holes. So feel free to go check it out. All right, I hope you found this video interesting. Let me know if you have any questions. I'll do my best to answer them. And I hope all is well. I'll talk to you guys soon. Take care.